Okay, hello everybody. Welcome to the Innovation Track. My name's Ivan Tolson. I work for Mindscape. We're a small tools vendor, developer tools vendor based in Wellington. And what we're going to talk about today is looking at some ways that we can program that are maybe a little bit outside the mainstream that will help us to maybe be a little bit more productive, a little bit more efficient, a little bit more expressive, and generally a little happier in the way that we work. Can people hear me okay? It's sounding a bit echoey to me. Is it all right? Are we good? Okay, sweet. So we're going to be looking at four main areas. We're going to spend most of the time on F#, which is a new language from Microsoft that's recently come out in Visual Studio. We're going to look at Boo, which is a third-party language, which has got some interesting little constructs that may be useful in specialized situations. We're going to look at the ability to host other languages so as to allow your customers or your configurators to customize your software. And we're going to look at DSL tools, which is part of Visual Studio, and again can help you with making your code a little bit more expressive. And then we'll briefly look at some stuff that's coming out from Microsoft Research that may point to future directions or be of interest. So C# and Visual Basic have been tremendously successful languages. They absolutely dominate the .NET scene. But they're essentially the same language. They're imperative textual languages that map very directly to the underlying constructs of the CLR. There are a few little bits of sugar over the top. So for example, you've got the for each construct or the using construct that abstracts away some of the low-level details of the CLR. But really, these things are just presenting those raw classes, types, imperative constructs of the CLR. And they're limited, although they're able to put those abstractions like for each and using over the top of that. If they don't put a construct in, if they don't put an abstraction in, it's very hard for you to put an abstraction in. For example, if you use Windows Presentation Foundation or Silverlight, if you've built controls in those environments, you probably have to declare dependency properties for those controls. And that's quite a verbose thing to do. You end up with like 4 bits of code, and if you decide to change the name of that dependency property, you have to change it in 4 places. You've got your CLR wrapper, you've got your dependency property declaration, you've got your property change callback. Because although you can write that code, it's error prone. Because you've got the code made explicit, people can go in there and they can tweak that code. For example, if I had a $1 for every time I've seen someone put business logic into the setter of a dependency property and wonder, well, when my binding changes, why isn't my setter being called? I'd have $3. That'd be pretty good. Or consider, how many people here have used Link to SQL? Link to SQL, reasonable number. How many people who use Link to SQL use the Link to SQL designer? How many people who use Link to SQL write the data context and classes by hand? That's more than I expected. You guys are bold. Why do so many people use the designer? It's because the writing the classes by hand involves a lot of boilerplate. Really you just want to say, look, I want to have a persistent class which is called this and it's got these 3 properties and they've got these data types. You don't have to write all of that stuff about property change notifications and deriving from table of T and putting it into the data context and so on. The designer takes care of all that for you. So it allows you to work at that higher level of abstraction of saying, I want a persistent class with these properties, rather than to write out that low-level code which actually implements all of those properties. So to me, C# and Visual Basic are pretty close to being the assembly languages of the CLR. They've got great tooling around them, but they really are very low level, they're not very extensible, and they're not adding a lot of expressiveness over the top. So the first of the languages that I want to look at as possible alternatives is a language called F#, and it's described as a functional object hybrid. Which means that it's primarily a functional language. It thinks in terms of functions, of methods, rather than in terms of classes and state. But because it runs on top of the CLR and it has to work with CLR classes, it's also happy to deal with the object-oriented paradigm. It's included in Visual Studio 2010. It's also available as a separate download, which you can use with Visual Studio 2008 or standalone via a command line compiler. And crucially, because it's a CLR language, it plays really nicely with other CLR languages. So for example, the fact that F# hasn't got good tooling for Windows Forms, or the fact that it can't really work with WPF at all, it can't work with XAML at all, isn't necessarily a problem. You can build your user interface in Windows Forms or in Windows Presentation Foundation. But if you've got logic that is better expressed in F# because of its functional algorithmic nature, you can have that C# code call into that F# code as a library. And it's very seamless, it's very transparent. I'll briefly just run through some of the F# features which are they were kind of new a little while back, but they've now actually surfaced in C# and Visual Basic. So for example, first-class functions, the ability to pass a function to another function is something that's considered characteristic of functional languages. But we've used C# and Visual Basic. We know about LINQ. We've passed, we know how to pass lambdas into where clauses and so on. So first-class functions are really .NET delegates. C# and Visual Basic are not pure object-oriented languages. The CLR is not purely an object-oriented runtime. It is an object-functional hybrid. F# just emphasizes the functional side over the object side. F# has got lambdas and closures, which will be familiar again from your LINQ experience. And F# has got type inference, which is a bit like the C# var keyword or the Visual Basic dim keyword without a type. But it's used much, much more extensively. You very rarely actually have to write type annotations in F#. For example, in C#, when you write a method, you have to specify what is the return type, what are the types of each of the parameters. F# is actually really good at figuring that out for itself. Let's take a look at an example. It's the last one. There we go. Okay, so this is what F# looks like. I'm not going to spend too much time on the basics, on the syntax, for which I apologise, but I kind of want to get on to the features that actually make F# a productive expressive language where C# is maybe falling short, but we'll just have a quick look at some of the basics. So here I'm going to demonstrate a little bit of .NET interop, so I'm going to bring in a namespace. Now I hope people can see that at the bottom there. So when I press Alt-Enter, it's actually running this code in F# interactive, which is an interactive shell for F#. So when I do that, you can see there that it's actually assigned that descriptions variable, and I can now just interact with that. It's a .NET dictionary, I can add things to it. But now here's one little construct that's a little bit unusual. If you're used to the try-get-value function in C#, you'll remember that it returns a Boolean to say whether it found anything, but it takes an out parameter to receive the thing that was found. And that's a kind of a gnarly piece of syntax. It's a little bit messy to deal with. F# doesn't like out parameters. It doesn't think they're functional. Functions should return values. Expressions should have values. There shouldn't be state, there shouldn't be out parameters. It should just be returning stuff. So when F# sees an out parameter in a .NET class, it silently kind of removes that and sneaks it round onto the return type. So in F#, dictionary.tryGetValue returns a tuple, a pair of values, the Boolean, whether it was found, and the value, what was found. And I can now do a let of two variables at the same time. In C# I can't do that. In F# I can do that. I can do that assignment of two variables at the same time. So when I run that, you'll see that both the found and the value variables have been bound. An idiom that goes with that is pattern matching. So I can also, here I'm going to use this match keyword to match on that tuple. And that's going to basically run through that set of clauses as though it were a switch statement and say, does the tuple match this? And it will match the first one because the true will match, it can match the first one if the value is found. And if that happens, it will capture the other bit of the tuple into the desc variable. So this is kind of like a let, but it's almost conditional. It's if the constant bits match, then the other bits get assigned. We've also got that underscore thing, which means we don't care about it. It's not interesting in that case. The other thing you can see there is that sum and none. That's kind of F#'s equivalent of nullable types. And I think of it as nullable types done right. In the .NET runtime, in C# or Visual Basic, the nullable type concept kind of mixes up null as a value, as a null reference, with the idea of we didn't find anything. F# explicitly distinguishes that with this sum and none discriminated union. And again, we can pattern match on that to extract those values. So let's have a quick run of that. We've got this getDescription function that's now been declared. So I can do a getDescription. That's not going to work. And then just need this fun little reward to make it run F# interactive, and you can see it's actually returned a sum of something. If I do a getDescription of Bob, there's nothing there, and you can see it's returned that option value none. So we've got a quite expressive way of describing the sort of nullable behaviour. We've got that interop capability. Which makes it easy to work with stuff. That's the other thing I want to highlight about this. Have a look at that getDescription method. Notice that's returning a value. It's returning an option of string. It's taking in a string, and when we created that, it told us, yeah, I've worked out that getDescription takes a string and returns an option of string. But I didn't have to write that. In C#, I'd have had to say what the return type was and what the input type was. But F# has actually gone and looked at the body of this thing. It said, well, I know, okay, I've got this key input parameter. What could that be? Well, it's being passed into try_get_value. So what does try_get_value take? Try_get_value takes a string. Key must be a string. That's cool. I can work that out. What gets returned? Well, it's either a sum or a none. That looks like an option type to me. The sum takes desc, which I know is a string because that's what the tuple type would match in the case of desc. Therefore, I can work it out. It must be returning an option of string. So we've not had to write a var keyword. We've not had to write type annotations. It's just worked everything out for us. And that makes it really kind of quick and easy to actually put stuff together. Other features that will be familiar from C# and Visual Basic, there's a feature called comprehensions, which is a way of expressing, for example, filtering and selecting, and that's very similar to link. And quotations, which are similar to expression trees. You can, rather than having your code actually run, you can have it built into an expression format, which you can then manipulate, you can modify at runtime, and execute if you need it. F# is, although it can do a lot of the same things that C# and VB can, it's idiomatically quite different. We work with it in quite different ways. For example, we've talked about the emphasis on functions rather than records. So the fact that F# supports options, tuples, these discriminated unions of sum or none or whatever, you'll typically write in F# functions that run against these simple data types rather than binding the methods in with their behavior. So again, if you looked at that code we were looking at just now, you'll see we didn't create any classes. We didn't declare a class to hold this stuff. We didn't need a sub-main or anything. We just put all of our functions at the top level. We were able to run them in the interactive shell, or we could run them as a program. So we don't have that whole object overhead if we don't need it. Another key idiom is immutability as the default behavior. So when you do a let, for example, that's an immutable assignment. If you try to reassign the thing that has been let, then F# will complain to you. It will let you do it in the interactive window, but if I come here and say let found equal true, it will complain because found has already been assigned. I'm not allowed to reassign it. I can have mutable variables, but it doesn't want me to. I have to explicitly opt in to mutability. I want to go to Crazy Town, and the reason it's Crazy Town is because one of the things that F# does is asynchronous and parallel programming, and in async and parallel programming, mutable state is a big no-no. It can really get in your way. So F# greatly prefers immutability. Similarly, the built-in collection types in F#, things like lists, are immutable. F# has got immutable collections like dictionaries, and by immutable I mean that when you do, for example, an add, it doesn't modify the list, so anything that's referring to that list keeps the same content. The add will actually return a new list or a new dictionary with the new value added. This ties in with this idea of everything in F# is an expression that has a value. In an imperative language, like C# and Visual Basic, you'll tend to think of statements, a sequence of actions that you want the program to take. F# doesn't want you to think that way. It wants you to think of a set of functions that you can apply to things. It wants you to think of expressions, and those expressions have got values. And those values might be void effectively, but they still have values. The other idiom, which we saw just now, is that F# interactive read, edit, print, read, eval, print loop. You can try it with code as you go. In fact, if you're writing a program in the main F# window, you can select some text, press Alt, Enter, and it will copy it and run it in F# interactive. So much for the things that, so much for sort of the F# basics, the things we're kind of already familiar with from C# and VB. Let's look at some of the stuff that is a little bit more unique to F#, the reasons that you might actually think about using F# in your application rather than sticking with C# or Visual Basic. I think one of the key scenarios, especially given the way that things are going in the cloud space, is the ability to do asynchronous computing. And F#'s got two main idioms for this, asynchronous workflows and asynchronous agents. And I'm going to take my life in my hands here and try and connect to the internet, and we'll see what the harvest may be. So the first thing I want to look at is an async workflow in F#. And there we go. So here I've got a very simple program that's going to go and connect to a number of websites, pull back the data from those websites, and actually what it's going to do is display the number of characters, the number of bytes that it pulled back. So it's not actually going to display anything terribly interesting. But we are going to see it's actually going to be able to connect to those things. Now it's doing that asynchronously, because when we connect to a website, we really don't want to be blocking and waiting for that to return. We'd be holding up the user interface, we'd be holding up other connection attempts. So there's two things going on here. Firstly, there's this for sites do an async.start, which is going to kick off something in parallel. What's it kicking off? It's kicking off this fetch function. And this has got something a little bit weird in it. It's got this async keyword. And that's introducing an async workflow, or an async block. The term workflow is the official one. What's going on there? Well, we're doing a mix of synchronous and asynchronous stuff. So we're doing a web request.create. That's all familiar. That's standard system.net. But look at this. This is slightly different. So now on that request, we're going to call async get response. And if we're doing that in C#, then async get response would kick off a request to the web server, and while that request had been kicked off, it would continue charging down the program. And then you'd have a callback somewhere else in the program that would deal with when the stuff came back. So your logic for dealing with this web request would be scattered over multiple parts of your program. What this let bang does in F# is it says, kick off that async request, yield the thread, and then resume it here, or resume here when you get the response. So I'm able to, by using that let bang and that async get response, I'm able to write this as though I were calling the website synchronously. And this is important because it's much easier to reason about synchronous programs. I can look down that list of things, everything's in one place, it's clear what the order of activities is, it's clear what order things are happening in, which it wouldn't be if I had that stuff smeared across multiple methods. But it's not actually synchronous. The F# runtime is making it look synchronous, is allowing me to have that synchronous authoring model without suffering the problems of a synchronous execution model. Does that make sense to people? You see how that's much nicer to work with than the async programming model in C#? Okay. We've got a similar thing down here. We can use the same thing over a stream reader. I can do an async read to end, and that let bang again will yield the thread so that other things can go in the meantime. And we're going to see if we can connect to the internet. You never can tell with these things. Let's bring it up. So let's create some requests, and you can see, yeah, there we go, bang. I don't know if you're able to see there, probably not. It did manage to kick off those requests in parallel. Unfortunately, we've hit that web exception. I'm not able to get a connection and show you that stuff working, so I apologise for that. I hope it's still clear what the model is and why the model is desirable. So if you're doing a lot of network activity, then F# could be a good language to choose for that particular subset of your program. Another async feature in F#, which again is trying to give you that same feel of being able to program synchronously in isolation while still getting the advantage of concurrency, is async agents. And these are handled through this mailbox processor feature. So what is a mailbox processor? It's something that you give it a delegate, effectively, and the mailbox processor starts up, and you can then call receive in a loop and process things independently. So if we have a look at this, what are we doing in our mailbox processor? We're kicking off another one of these async workflows. We've got another one of these let bangs, which says, I'm going to wait for a message, but I'm not going to block the thread while doing it. So other agents can run on that thread. Other agents can reuse that thread. When I get a message, I'm going to match it with this discriminated union. I'm going to do something appropriate. Either I'll increment my counter, or I'll print a message, or I'll just stop. So what happens if we actually run all this stuff? Let's get that in F# Interactive. No, we don't like that. We need to open some junk. So there we go. So I've now made 3 of these mailbox processors, 3 of these little counting agents, and they're all sitting waiting for a message. So what I can do is I can now post a message to C1, and that's now going to go away and process that message, and it's doing that asynchronously. So while it's busy, I can do something similar to the second agent, and now I can post a print message to the first agent, and you can see it's got that incremented value. It's running on a particular thread. Now if I post another increment message to C1, and then quickly afterwards post a print message, C1 is actually still busy doing its asynchronous stuff. It's still busy processing that increment, which we imagine in this case is going to be something like a network operation. But eventually, after about 10 seconds, yep, it comes back, it checks its mailbox again, it sees that print message, and that pops up in F# Interactive. So you can see we've now got those 3 counter agents all running independently. Each of them kind of thinks it's running synchronously. You can reason about it as though it was synchronous, so it's quite easy to understand how it works, but they're actually able to make use of those multiple threads to do stuff in parallel. They're also isolated from each other, so they can only interact with each other via messages, via doing something like a post, and therefore they can't interfere with each other's state. There is no shared state between those agents, so you're protected from data corruption and from race conditions. Does that make sense to people? Can you see what's going on there? Not sure. Okay. Hopefully you can. Another intriguing feature of F# is the way that those async workflows work. We saw that let bang construct that would yield the thread and resume it only when the async response came in. That's not the definition of let bang. Let bang is not hardwired to async programming. What let bang does is it actually looks for it means go look at the block that you're enclosed in, go look at the workflow that you're enclosed in, and ask that what you ought to do. So we can actually change the meaning of let bang, do, yield, using, for, while. We can change the meaning of a lot of F# keywords by putting them inside one of these computation expression builders. Async is one that's built in, and obviously does the very useful async composition of expressions. We can also use it for designing sort of little mini languages for particular business domains. So if we have a look in here, I've got validation logic for a customer. So I'm basically doing a risk assessment on a customer. It's obviously very simple. And this is kind of the traditional way that you might write that stuff. And you can see there's a bunch of nested if-else clauses. I don't want to do more validations. I have to, because maybe they're expensive in terms of time, or I have to pay for certain validations. So I want to bypass them as fast as we can. So as soon as I get a failure, I want to stop at that point. The if-else logic, in this case, is only 2 checks, and it's therefore very, very simple. If you imagine there's now like 100 checks or 200 checks, you can imagine that logic is going to get a little bit messy. What I'd like to do is to be able to just write a sequence of checks, a sequence of expressions that I want F# to look at, to evaluate, which can maybe accumulate information about the customer. But once they hit a failure, they just bail out. And I don't need to write if-else logic to do that. I just want it to stop. So here's my dream code. I'm just doing a couple of let bangs. Do the check credit, do the check criminal, and I'm wanting it to, if the check credit fails, I'm wanting it to not proceed to the check criminal. And the secret is in this let bang keyword, because I'm putting this in an attempt workflow. And attempt is an instance of something called an attempt builder, and this attempt builder has got this bunch of rather wacky looking functions: return, bind, delay, let, and those provide the definitions for things like let bang and return and do within that block. So when in the test workflow that let bang executes, it actually ends up calling this b.bind function, passing in the statement that the expression it wants to evaluate and the rest of the workflow. And the F# compiler understands this idea of a workflow builder. It understands how to resolve these special keywords, and it basically translates them into these method calls. And the way that I've written bind, if we look further up here, is it's going to look, do I get a failure? If so, I'm going to fail immediately. Do I get a success? If so, I'm actually going to run the rest of the statements. I'm going to run the rest of the workflow with the result that I got that was successful. So this is pretty heady stuff. It's actually, I think it's pretty hard to get your head around, but hopefully we'll be able to see just quickly how it actually runs in practice. So here I'm going to pass the credit score, but I'm going to fail the has criminal record. So we're going to hit that first break, we're going to hit that second breakpoint, and we'll see the workflow effectively running to completion. There we go, we've hit that. That's going to pass. We're going to execute that. And we get our result. On the other hand, if we give this dude a bad credit score and run him up, then although we still execute the first line of the workflow, we hit that breakpoint, we don't hit the second breakpoint. Because that first expression failed, F# has figured out, or F# has delegated the bind expression, which has said, don't bother running the rest of this stuff, just fail immediately, don't run the rest of the workflow. So without having to write any if-else logic, I've been able to do that sort of conditional processing, or that conditional composition of expressions. Can people see roughly what's, I know this is pretty highfalutin stuff. Can people see what's going on there? Okay, sweet. What else has F# got? We've got a parser generator that comes as part of the F# Power Pack, which is kind of a standard library, one of those must-install things. And you can use this to provide little macro languages or expression languages for your customers if you need them to be able to enter, say, formulae or something like that. So here we've got sort of definition of a simple expression language. An equation is a discriminator type. It's got an expression in it. An expression could be one of these things. What could these things be? Their terms. And eventually it all comes down to parenthesized numbers, plus, times, and so on and so forth. We define the tokens that we understand. And again, pretty simple. We want to ignore white space. These are the tokens we want to recognize: parentheses, arithmetic operators, integers, and floats. And then we have a parser that defines things like the precedence of these operators. So this is very simple language. We run the F# tools over it, and it'll generate something that you really don't want to look at. There we go. Oh, baby. It's good. But fortunately, we don't have to look at that stuff. We can just use it. So in our program, what we're going to do is we've got a little bit of an incantation here. We're going to feed we're going to do a read line, feed that into this eval function. That's going to pass it to a magic incantation that does something called lexing, and that's going to pass it into the parser, and that's going to pass the result into eval. Eval is going to use that AST, that discriminated union of equations and terms and factors and things, and it's got rules for figuring out how to evaluate those things. So, for example, if it sees a times instance of the discriminated union, it will evaluate each side and multiply them together. What's the upshot of that when we actually run it up and type it in and start typing stuff in? Let's try 1 plus 2 times 3, and it's able to figure that out. We also can see that it respects precedence, so those brackets have been correctly interpreted. So that gives you an opportunity to introduce some simple mini languages into your program. If you need customers to be able to input maybe rules or expressions, simple rules or expressions, then you can do that using F#. You don't have to write your own low-level text processing stuff. You can use the parser utilities in F# to handle that for you. Last one I want to mention is units of measure. How many people here have worked on $60 billion rockets? I'm disappointed. I was hoping that somebody had worked on a $60 billion rocket, had mixed up feet and meters, and seen the rocket crash about 60 meters above the Pacific. Because it happened to some guy. I don't know who, but man, that would be bad. F# has actually got the concept of units of measure built in. So, for example, we can declare these types. So I can declare miles, kilometers, hours, and so on and so forth. And for example, if I let total distance equal distance 1 plus distance 2, F# is not happy about this because it knows that distance 1 is in kilometers, distance 2 is in miles. So it's saying, well, hang on, you can't add miles and kilometers and expect to get anything meaningful. Obviously, I could put a conversion factor in there. I could put in a constant that expresses the translation. I could multiply things by that constant. And once the dimensions, once the units of measure are all the same, F# is happy to add things together. But if I just try to dumbly add miles and kilometers, it says, no, that's really not a good idea. The Ariane 5 boys will not be happy with you. You also notice we can use derived units of measure. So, for example, we can express a speed in kilometers an hour or miles an hour or whatever. Similarly, if we were to say divide a distance by a time, that would still be a typed value of kilometers per hour or whatever. So this is just a little way that may help you to avoid errors in, for example, scientific or financial computation. Dealing with multiple currencies, for example, could be another way that you might want to avoid errors in adding dollars to, what's the currency in Zimbabwe? Anyway, you don't want to add to it because they've got enough already. So, we mentioned scientific and financial computation as a couple of the business domains that F# particularly excels in. There's one more that I want to highlight, and it's a business domain that I actually find quite hard to deal with, and that's the business domain of Terrans and Zergs. So, this is a little demo that a guy called Chris Smith on the F# team put together, and it's, I think, the only chance I'm going to get to play StarCraft at TechEd. And it's only StarCraft 1, unfortunately, now. Come on. There we go. So, you can see I'm not an expert on StarCraft. So here we've got a C# application. That client is a C# dialog, but it's able to talk to an F# library. If we now run up StarCraft, don't fail me now. There we go. Chunk, chunk, chunk. There we go. Custom game. There we go. And you can see at the moment I've kind of been dumped into a default game. It's not really doing anything. That C# client has detected that a game is running, and it's now ready to load an F# based AI. So at the moment these guys are doing absolutely nothing, which is what my units usually do in games like this, because I'm completely baffled by them. So fortunately, I can turn on this F# AI, and this has now got little rules in it that tell it, go look for worker units. When you find a worker unit, go look for any nearby minerals and go mine them and produce fantastic stuff out of them. And I've now exhausted my entire knowledge of StarCraft. I'm really sorry, guys. Why is F# an interesting language for this? It's because of the asynchrony feature. This example, which you can get from Christmas blogs, doesn't really make a lot of use of it. But for example, the StarCraft API, when you want to talk to another unit, that is an asynchronous call. You want to go looking for enemy units, for example, that is asynchronous. And therefore, the F# asynchronous constructs are really handy for that. So I know that's going to be an important application for a lot of you guys. One other handy little application which I don't have time to demonstrate, IntelliFactory Web Sharper platform. This is basically a website, a way of building websites in F#. And the idea is that it gives you kind of that static type safety that things like F# and C# give you. So rather than declaring forms and have to manually map data between your form and your data type, your form is kind of built by Web Sharper around your data type. So you can create, say, a login page record with username and password record fields, and that's a pure data type. And you can then say, make me a formlet for this, and it'll produce you a formlet of login record. And you know you'll be able to compose that in a type-safe way with other formlets. It's an intriguing thing. I don't have time to demonstrate it, but it's worth checking out. It's by a bunch of guys called IntelliFactory. It's a free download. Okay. I want to move on to some other constructs now. Boo is a language it's an open source language. It's been around for a little while. I think it's almost as old as the CLR itself. And for the most part, it's kind of almost like a statically typed version of Python. It's intended to be quite a concise language, but it's quite similar in its capabilities to C# and Visual Basic, except for its extensibility mechanisms. If you're familiar with, say, the Visual Basic or Delphi with statement, I know it's a kind of controversial thing. Some people love it, some people hate it. But let's imagine, for the sake of argument, that we love it. And we wish we had a with statement in C#. What the with statement does is allow you to say with some object, and then you can call methods or properties on that without having to keep repeating the name of the variable. And this allows you to be quite concise in your presentation of stuff. C# does not have that construct, and it has no way of adding it. C# is not an extensible language. We cannot create that new expressiveness in C#. In Boo, we can. There's this feature called macros, which allows us to do exactly that. So, there we go. So, what I want to be able to do, go away. Is here's a variable with a really long name, and what I'd like to be able to do is say with that variable I want to set these two properties and then call that method. Now Boo doesn't have a with keyword, so it seems like I can't do that, but what I can do is I can define a macro. You don't like my line endings. And when this macro gets compiled, so the magic is that it derives from this class called abstract_ast macro, and as Boo compiles that with statement, it will go, I don't understand what this is. Have I got a macro definition for it? And in this case, it will go, yep, I've got this with macro class, and because it's called with, the macro thing, like C# attribute, can be elided. Says, okay, so I'm going to pass the contents of that expression, the contents of this with thing that I don't understand, I'll pass to the macro, and the macro can then turn those into code. So the macro is going to look through each of the expressions that go underneath it, and if it starts with an underscore, it's going to transform it into a member reference expression on the appropriate thing and replace the current node in the compiler syntax tree with that expression. So when I build that, I run the Boo compiler and pass in both the macro definition and the macro and the example of usage of the macro. And you'll see that even though the with keyword doesn't exist in Boo, it has successfully compiled. And if I run the resulting program, you can see that F1 field was assigned, the do something was run against that same instance. So it's successfully transformed that syntax. We've added a new syntactic construct to the language. You can actually go further than this. You can build whole new DSLs in Boo because of this. It's got a feature called the extensible compiler pipeline. So you can actually insert your own code into the process of compilation. This allows you to introduce, if you like, contextual keywords, so almost globals, so that somebody say you can create a DSL that your BAs can use, for example, and they can just refer to things, and the compiler will figure out those things that they're referring to. They don't need to write all of those import statements or use class names or anything like that, because you've added some logic to the compiler that will figure that stuff out. We'll have a really brief look at this. There's a book called DSLs in Boo by a guy called Allende Raheen. It's a really eye-opening book. If you're interested in writing little languages for people like BAs or for yourself to use, it is an absolutely stunning book, well worth a look. It will really open your mind to what can be done with this stuff. So this is an example of a quote generator, and you can see it doesn't really look an awful lot like a programming language. It's simple enough that even a BA could use it. I mean, obviously a smart BA, but you know, if you found the right BA, they could use this to write specifications of how your systems might be configured, for example. When we want to use that, again, this is using libraries from the Raheen book, and we're just going to do a quote generator.generate. What's happening behind the scenes with that? Well, it's using this thing called a quote generator rule. What's that? And that's something that provides implementation for these specification, requires, users per machine, same machine as keywords. So those keywords are not defined in the Boo script itself. Those keywords are being defined in the compilation process. This rule is being injected into the compilation process by this widget. Are you going to let me see that? Yep, there you go. So this is implementing, again, a class from the book, and it's inserting this quote generator rule into the pipeline at an appropriate stage. So around the, it's at the evaluation stage, I believe. So when symbols are being evaluated. So we've been able to effectively, again, add keywords to the language, an interpretation of those keywords to the language, in such a way that we can create a script-like mini language that we can use that is specialized to that domain of quote generation. And similarly, I'm sure you can imagine similar configuration areas in your own applications, in your own business domains, where, again, being able to configure with the power of a full language is potentially quite useful. Another way of handling that configurability, that extensibility, is to allow scripting of your own application. So if you've got something that potentially manages a lot of objects, it's got a lot of data that people might want to work with, you may not be able to anticipate everything that people want to do with all of that stuff. And if it's a closed application, then you're kind of stuck, or your users are kind of stuck. They have to come to you and say, I want to be able to do this. I need a button to add new things. I need a button to do this kind of analysis. If you've got a technically savvy support team or a technically savvy configurator or technically savvy users, one option is to embed a language that they can use to program your application. And with PowerShell and the dynamic language runtime, that becomes pretty easy to do. Those languages are out there and they're available for use. So let's take a look at that. So here I've got a simple WPF application, and if I run that, you'll see, as with all of my WPF applications, it has a powerful and info-sensitive, info-dense user interface. This is for visualizing balls, so you can see it's pretty clear what's there and what they're doing. So what about this mystery text box, though? Well, let's have a look at what happens if I start typing some stuff in there. I'm able to look at the collection of things that are in there. But it goes beyond that. I can modify them. So, for example, I can say this guy wants to be closer over to his neighbour. wants to move there. I can create variables. So I've created a new ball. I've not done anything with it yet. Let's just set some properties on that. And now I can keep referring to that variable. It's remaining in scope. I can keep using it so it's a real programming language. It is a real programming language. And when I do that add, it appears, because I've added it to that balls collection, it's a WPF application, it's just data binding, and therefore the ball now appears in my items control. So how much would you pay for that feature? Would you pay 1,000 lines of code to be able to embed Ruby or Python into your application? 1,000 lines of code. Bargain? 500 lines? Anybody? Any more takes at 500? 100? Oh, come on, guys. 100 lines of code. It's a bargain. 10? 10? We reckon 10? We're going for 10? Okay, let's take a look at what it takes to embed Ruby into your application and make your stuff accessible to Ruby. Okay, I'm counting 1, 2, 3, 4, 5, 6, 7. 7 lines. And we've got a full programming language, all the power of Ruby, inside our application, just waiting for our users to type bizarre syntax errors and throw everything into higgledy-piggledy. Which I think kind of illustrates part of the problem. I think this is a fantastic opportunity. I think the fact that it's easy to embed these languages is terrific. But having said, wow, you can do it in 7 lines, there's also that brings in a whole bunch of issues along the lines of how do I document this stuff? How do I cope with errors? How do I provide feedback to users? How do I allow them to debug things if it gets fancy? So the 7 lines are the easy bit. The making it a product is always the difficult bit. But as you can see, if you want to allow that kind of extensibility, you've got that full programming language available. It's very powerful. Okay. We talked about Link to SQL and how using the designer was allowing you to work at a higher level of abstraction if you were typing the code directly. And in some areas, this is a pretty common issue. There's a lot of things that may require boilerplate code, like the Link to SQL table table declarations. One of the products I work on is an object relational mapper called Lightspeed. If you want to create associations in Lightspeed, you have to create a foreign key in one place, you have to create an entity holder in one place, and you have to create an entity collection in another place. It's about 10 lines of code. I don't have time to write 10 lines of code. That's just crazy. I can only do 7. So what do you do to get around that? The idea is that you can create a graphical language that integrates into Visual Studio using something called the DSL tools, or as I think it's now known, the Modeling and Visualization, Visualization and Modeling Toolkit, because that's a much snappier name. And what this allows you to do is create these graphical languages that integrate into Visual Studio. You can then use a custom tool or a T4 template to generate C# or Visual Basic code. So your users will work with that high level of abstraction, that visual diagram, which just exposes that key bit of information, and you can spew out as much boilerplate code as you need to. But people will not see that. They'll just work with the high-level abstractions. We don't have time to run through a fully fledged demonstration of that, because actually building up a DSL takes a good hour and a half. That's how hard it is. But I will show you some bits of the Lightspeed one. So for example, here we've got the idea of an entity, and it's got a bunch of stuff on it, but that's kind of off in the properties window. No one worries about that too much. And it's also got associations on it. So for example, we've got these connectors. These orange things are relationships between domain entities. And it can also have a subset of, a set of properties. And these are represented on shapes. So you can see we've got somewhere here we've got an entity shape that will show the collection of properties, and we've got connectors that represent those associations. So when I run this up, it will appear inside Visual Studio. I don't actually have this hooked up to a code generator under the debug, so unfortunately I can't show you that, but hooking it up to a code generator is not actually a problem. It's pretty easy to do. Here we go. Here's my test solution. Yeah, I know about that. And you can see it's generated all these toolbox items for me. I can drag things on here. I can add properties to that compartment. I can rename stuff. I've got things like being able to set a data type down, because I've declared data type as being a property of entity property. It's appearing in that properties window, and I can drag associations between these things. And when I save, it will generate that low-level code with all of the boilerplate that people would otherwise get wrong. It will generate correct code based on that higher-level abstraction. And you can use this, of course, in any domain. If you've got, say, a class library that you make a lot of use of, that you reuse in many different applications, there's something like DSL tools may be a good way of providing a visual way of working with that class library. That's built into VS 2008 and VS 2010. There's no additional redistributable components for that. Okay. So that's all I really wanted to cover in terms of the of coding technologies that I think you can be using today, that I think you can use maybe in niches, but to make yourself a little bit more productive, get a little bit more expressiveness out of the .NET framework. And I just want to briefly mention a few projects that I kind of had a little bit of a wander around the Microsoft research site and just thought, these could be interesting. These could be things that maybe developers want to play with, want to know about, just see how they're going. So just a very brief overview. Microsoft Research are working on a language called Axum. And Axum it's been described as C# meets Erlang. Erlang is a language specifically designed for concurrency. So if you remember what we saw in F# with those mailbox processor agents, the idea that you could create these multiple mailbox processes, multiple agents, and they'd all kind of jump onto threads when they needed them, and they'd go quiescent when you didn't need them, and they could send messages to each other, and they could generally interact while retaining a high degree of isolation. In Axum, that is actually baked into the language. The language has operators, it has keywords specifically around isolation, around agent creation, around messaging between agents, around data flow between agents, around the coordination between agents. It's specifically built for that kind of concurrent programming. There's a preview available now. I think it's version 0.3. No matter how much concurrency, no matter how much you like concurrency, don't bet the company on Axum. It is a research project. There is no commitment to shipping it as a standalone language. My feeling is that what will probably happen is that concepts from Axum will get folded into future versions of C# and Visual Basic, but I can't, I've got no special insight there, I don't know. But it's an interesting language to at least get you thinking about concurrent programming, and if it works for maybe your subset of what you're doing, then it could be worth having a look at, particularly if it's not a mission-critical piece of software that you need to ship externally. We're going to talk, I've got to talk later on about the parallel frameworks in .NET and how parallel extensions can enable you to distribute work across multiple cores. Microsoft Research have got a project that allows you to distribute work not only across multiple cores, but across multiple machines. And this is this Dryad thing, distributed parallelism, and they've also built this layer on top called Dryad Link, so that you can basically write a link query and say, I want this link query farmed out across a whole cluster of machines. Not just multiple cores, the link query will be processed in parallel efficiently on multiple machines. That, I believe, is currently available only as an academic release. It's from Microsoft Research. Again, if you want to do heavy distribution, it could be worth getting in touch with them. Every programmer contains a 4-year-old child. So bright colours, happy icons, this is what we want. And you can actually use the Kodu language on your Xbox. None of this mucking around with keyboards and things like that. The interesting thing about this, I think, from a programmer point of view, the reason I've sort of mentioned this as an innovation, is the way that it uses primitives that are appropriate to the domain. So instead of the primitives being things like integers and while loops and equality tests, the primitives are things like collisions, colours, vision, hearing, time. Those are the core concepts of this visual language. So it's operating at a much higher level. It's operating at a level of abstraction appropriate to the gaming domain. Again, technical preview, available from Microsoft Fuse Labs, available for download. Last one, I think these are actually available as Visual Studio Power Tools. I think they're on the Code Gallery. They're certainly available from Microsoft Research. These are a couple of testing tools which I've not had the chance to play with, but they really look very interesting, very cool. The idea of PEX is that it will look at a method and it will statically analyze the code of that method and figure out what are the different paths, what are the different interesting cases. So, for example, if you've got, say, a method that takes different code paths depending on whether the input is negative, 0, or positive, it'll make sure that you've got tests generated for all three of those cases. So it'll actually figure out what are the interesting cases, what are the different scenarios that we need to test for, and it will generate you a test suite that covers those things. So I think it's pretty smart, and I think it would certainly help me. Another little thing that goes along with that, there's a tool called Moles. This is kind of if you want to use mocking. So if you've got, say, something that works, that behaviour involves consulting datetime.now because it wants to check, is it before today or is it after today or whatever. That's a pain to use in a test suite because it kind of, every time you run the test, datetime.now changes. So how do you put in reliable test data? Well, Moles will allow you to essentially detour around to replace any .NET method, even the built-in ones, with your own method, with your own delegate. So you could replace, for the duration of that test, you could replace the datetime.now method with something that returns a fixed date suitable to your test data, which again I think is pretty clever and pretty handy. I know there are some tests that we have that are vulnerable to this. So, just to wrap it up, there's no law saying you have to use C# and Visual Basic. They are the dominant languages. They have fantastic tooling. They're very productive at what they do. But sometimes you're going to run into situations where C# and Visual Basic are just not expressive enough or not expressive in the right way for what you want to do. And at that point, it's great to have these other tools in your toolkit that you can reach for and say, I need to do some really heavy asynchronous programming. I'll just drop that into an F# library. I need to present a higher level of abstraction. Well, I'll use DSL tools to put a layer over the top of my complicated code. So specialized features and expressivity are both great reasons to be thinking about maybe using another language, another technique, rather than sticking to C# or Visual Basic. That said, technical fit is not the only consideration. My friend Steve likes to rant about savants. He calls them savants. These people who are kind of too clever for their own good. They know all the clever niches of technology, and they'll go, oh yeah, I can use F# for that. Rattle, 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 rattle. Fantastic, shipped in half an hour. You guys maintain it. I'm off. What? It looks... So you need to be thinking about that. These are smaller languages. The developer pools are not as big. People may need training up. Your support guys may need to know about them. So just because the technology is a great fit doesn't mean you necessarily want to be diving in there. You have to think holistically about your product, about your project. How is this stuff going to stand up over time? You do not want to be the guy that Steve is ranting about. I've heard him ranting, and you do not want to be on the receiving end of that. But you're on .NET, and that gives you a huge advantage. You can mix and match. You don't need to commit one way or the other. You can use as much or as little of these languages, of these techniques, as you like. We saw the StarCraft demo where we built the Windows form in C# and the AI in F#. Great division of labour because C# has got great tooling for building Windows forms, and Visual F# has got a console window. Visual-tastic. But we were able to mix and match. We were able to build that UI in C# and have it call down to F# to do the asynchronous and algorithmic work. So you're able to pick best of breed. You're able to combine these things in really nice ways through the ability of the .NET runtime to do the language interop. Similarly, the ability to call into dynamic languages. It's all enabled by the .NET runtime. So that, I think, for me, is the key takeaway. Use these tools where appropriate, and take advantage of the fact that they work together so very, very well. Have the bravery, have the boldness. You're on the innovation track. You wouldn't be here if you weren't being bold, if you weren't feeling bold about trying things out. Take a look at what's outside the valley of C# and Visual Basic. Use it where appropriate. Be on board. Thank you very much for your time.